So let's go back to our lab setup for a minute, and we're looking at 3 different lab setups. Notice they've got the same masses attached to the pipes, but they're at different locations away from the pivot point. And in each case, we've got essentially almost a kilogram hanging off of there. And so we almost have 10 newtons of force of tension on each, which is leading to a certain amount of torque. So they're experiencing the same amount of tension, experiencing the same torque, but they have different rotational inertias. Remember, which one of these things would have the largest rotational inertia, the largest resistance to angular acceleration? Well, it's going to be the one that has the mass that's the farthest away from the pivot point. That's going to be this one right here. And which one would have the least rotational inertia? Well, again, all these things have the same total mass, but where the mass is relative to the point about which the thing rotates matters. Here the mass is closest, so it should have the lowest rotational inertia, the lowest resistance to angular acceleration, so therefore a torque is going to give it the biggest angular acceleration. And this guy over here should have the largest rotational inertia, the most resistance to acceleration, so for the same applied torque, the same net torque, it's going to have a smaller angular acceleration.